Hey, I've got another integral. We're looking at the integral from 0 to infinity of x cubed e to the minus 2x to the 8th dx. Okay, looks pretty tricky. Let's see what we can do. I think what I want to do first is just focus on my exponent. What I want to do is deal with this as a square. So let's rewrite this as square root of 2 x to the 4th all squared. And I'll rewrite the whole thing. And then I think at this point what I want to do is just kind of notice the similarity that we have to the Gaussian integral. So we have this very useful formula for the Gaussian integral over here on the right that tells us if we have an integral in this form, our solution is going to be square root of pi. Now the second formula comes directly out of this, just because this is an even function. For an even function, you could adjust the bounds, bring a 2 out front, divide by 2, and you have square root of pi over 2. So since we have our 0 on our bounds, we'll be using this second formula, or shooting for this. But you notice we have this problem here. We got this x cubed out front. So even if we do a u substitution, it's not quite clear how this is going to work, but let's see if we can manipulate it so that we can use this one over here. I'm going to make my u this stuff right here, so we're going to call our u square root of 2 x to the 4th, and then we'll take our derivative, so our du is going to be 4 square root of 2 x cubed. And really that's not so bad because we have our x cubed right there. So what I want to do to make this work nice, let's just kind of pencil in a marker of 4 square root of 2, and then so we're not changing it, we'll divide by the same thing out front. And then I'm going to go ahead and just make my substitution. So we're going to have 1 over 4 square root of 2, plugging infinity in here, infinity to the 4th, that's still infinity. Plugging a 0 in here is just going to be 0. Then let's look at our e's. We're going to have e minus, this is just u right here, so we're going to have e to the minus u squared. And then this with this is just our du. And now we have this in exactly the form we want. So we know that this thing is square root of pi over 2. So let's see how this is going to work. We have what we have here. We're going to have 1 over 4 square root of 2 times square root of pi over 2. I think just to clean it up a little bit, I think what I'll do is multiply this 4 times 2. We're going to have 1/8, and then we'll have square root of pi over 2. I got this problem for my quiz, Gaussian Integrals. I'll provide a link in the description. Hope you check it out. It has a few different varieties, and it's still in progress. I'm going to be adding more to it. So we'll provide a link for that. Thanks for watching. Have a great day.